Hi there, my name is Dr. Deshawn, and we are going to find intercepts of curves in this video. I have a diagram on the screen here with a little bit of an explanation, but the diagram will show you what the intercepts actually are of a curve. The x-intercepts it would be where the curve intercepts the x-axis, as the name implies. The x-intercepts just where the graph crosses the x-axis. The x-axis points, any point on the x-axis, you're going to have a value for x, but you're always going to have a 0 coordinate for the y. Every one of those infinitely many points on the x-axis, you have a 0 for the y. So when you're solving for your x-intercepts, you would set the y coordinate to be 0, the y value to be 0, and you solve for x, and that's how you'd find them. Where does a graph cross the y-axis? Well, where it crosses the y-axis, to find the y-intercept, every single one of the infinitely many points on the y-axis has an x-coordinate of 0. You would set the x to 0 to solve for the y-coordinates. All right, so let's take a look at some of the examples up here on the board. We'll do a total of 3 examples. So we'll do three different style of examples. Our first example right here, we have y equals x squared minus 5x plus 6. So we want to find the intercepts for the graph. All right, finding the intercepts of the graph will help you graph it. Okay, so it helps you graph it by hand especially. So let's go ahead and see what we have here. Let's start with finding the x-intercepts. So to find the x-intercepts here, we're going to set y equal to 0, and then we're going to solve for x. I'm going to move over here so you can see the work. So we're going to take this equation, you just substitute 0 in for y equals x squared minus 5x plus 6. Just make that substitution. Now we need to solve this quadratic. So we need to solve this quadratic over here for x. So to solve the quadratic, we need to take these 3 terms on the right hand side. We've got to make it one term. So we want to factor, we're going to have to factor it to make it one term. So let's factor our quadratic. So we have 0. So we can factor. This is factorable. The factoring doesn't always work, but it does in this case. And so x times x is x squared. We need 2 numbers whose sum is negative 5 and whose product is a positive 6. So let's try negative 3 and negative 2. So there's your x squared, negative 3x minus 2x is your negative 5x, and there's your positive 6, okay? So when is this expression equal to 0? Well, once you get your 3 terms written as one term, you can go ahead and set each factor equal to 0 and solve. So add 3 to both sides here, x equals 3. Set each factor equal to 0, so x minus 2 equals 0. Add 2 to both sides, so x equals 2. So here, so your x-intercepts, so what do we call our x-intercepts? Well, you like to represent them as ordered pairs because they are points on your Cartesian plane. So the x-intercepts, well, you have when x is 3 and y is 0. This is one of them because when x is 3, remember your y is 0, that's how we started this. And when x is 2, y is 0. So you have, these are your x-intercepts for this graph. And now let's go ahead and find the y-intercepts for the same curve. So we know where this curve crosses the x-axis. It crosses the x-axis at 3 and 2. Let's see where it crosses the y-axis. To find the y-intercept, we're going to set the x value equal to 0. So we're going to come up here, rewrite the equation. So y equals, but make a substitution. Substitute 0 in for x, so 0 squared, minus 5 times 0, and a positive 6. Make that substitution. 0 squared is 0. 5 times 0 is 0. So your y-intercept will just be 6. All right, and we could write that it's Cartesian plane, write it as an ordered pair, so you can see right here. So when x is 0, y is 6, and so here's your y-intercept, and here are your x-intercepts. The answer to example number 1, your x-intercept will be at 3020. Your y-intercept will be at 06. So we're not graphing these yet, but gives you an idea of what the graph looks like. It helps you when it comes time to graph these. Here's your y-axis, here's your x-axis. So we have this curve crosses the x-axis at positive 2 and positive 3. Okay, so positive 2 and positive 3 might be about here. Okay, it's not drawn to scale. And it crosses the y-axis at a positive 6. Okay, so crosses the y-axis at positive 6, which is, positive 6 up over here. Okay, so what does this graph look like? You'll do more work later on to figure out what's going on here, but this graph it's actually a quadratic function. So this graph right here actually is a parabola, opens up, and you have the vertex between 2 and 3 here, but that's what the graph looks like. So I'm not getting into the graph yet, but finding intercepts of a graph certainly helps you figure out what the graph looks like. All right, let's look at example number 2. Example number 2, we've got 4x squared plus 9y squared equals 36, okay? So we want to find the x-intercepts and y-intercepts here. To find the x-intercepts, remember what we do? To find the x-intercepts, substitute 0 in for y, solve for x. Wrote the instructions over there. So to find the x-intercept, keep the x, substitute a 0 in for y. So you have 4x squared plus 9 times 0 squared equals 36. Substitute 0 in for y. It makes that term go away. So we have 4x squared equals 36. We're here. Now we want to solve for x. Okay, well we have to divide both sides by 4 first. Okay, so we want to isolate the x, but let's get the 4 out of the way first. Divide both sides by 4. 4's cancel, so x squared on the left side, and then 36 divided by 4 is 9. X squared equals 9. Now, take the square root of both sides and be careful. What number can you plug in for x, square it to get 9? It's plus and minus 3. Okay, positive and negative 3 for this. Positive and negative 3. 3 squared is 9, negative 3 times negative 3 is 9. So we can write the intercepts. We have 2 intercepts here. You can write positive 3, 0, okay, because y is 0. You can write negative 3, 0. These are your x-intercepts for this curve. You have 2 of them. Let's find the y-intercepts. Find the y-intercepts. Take our equation, we substitute 0 for x. All of the infinitely many points on the y-axis have a 0 for an x-coordinate. So we're going to take this equation and substitute the 0 in for x here, okay? Plus 9y squared equals 36. We want to solve this. The 4 times 0 squared is 0. This term goes away, so you're at 9y squared equals 36. We want to solve for y. We want to solve for y, so divide both sides by 9. Divide both sides by 9. The 9's cancel, so you have y squared on the left. The 9's cancel, so y squared equals 36 divided by 9 is 4. So y squared is 4. We want to know what y is, and again, be careful, plus minus 2, the square root of 4. You want to take this, so 2 times 2 is 4, negative 2 times negative 2 is also 4. So what are your y-intercepts? 0 on the x, 2 on the y, 0 on the x, negative 2 on the y, and these are your y-intercepts. So they help you get a picture of what the graph might look like if you wanted to investigate. Here's our y-axis, x-axis. We can plot these and see. On the x-axis, we're dealing with positive 3 and negative 3. On the y-axis, we're dealing with a positive 2 and a negative 2. All right? This graph here intercepts, crosses the x-axis at plus and minus 3, crosses the y-axis at positive negative 2. So what does this look like? It just so happens that this curve right here is an ellipse. It is an ellipse, and those are the intercepts with the ellipse. So, and once you find the intercepts, you can go and look for the major axis, the minor axis. There's a lot of things you can do once you set that up, right? So here's your second example. We've got one more example to do. We're going to find the intercepts of a radical expression next. So we're going to deal with a radical expression. We've got a parabola. Took care of an ellipse. Let's look at the zeros of a radical expression. So let's do example number 3. Erase this, move this out of the way. So example number 3, the radical example. I'm going to move all this out of the way. So let's erase. And we'll find the x and y intercepts. Just remember the x-intercepts, where it crosses the x-axis, you would set y equal to 0. The y-intercepts, where your curve crosses the y-axis, you would set your x-coordinate equal to 0. All right, so let's do example number 3. Example number 3, y equals x minus radical x plus 2. X minus radical quantity x plus 2. So we want to find the x-intercepts. All right, there might be more, and we want to find the y-intercept. Okay, so let's find the intercepts here. I'll put a parenthesis around there in case there's more than one. So to find the x-intercepts, set y equal to 0. Okay, so set y equal to 0. 0 equals x minus radical quantity x plus 2. How do we solve this? Okay, there's a radical expression involved, so we want to get rid of the radical. So we'll have to square to get rid of a radical, but not until we isolate the radical first, okay? So we want to isolate the radical expression first. In this case, we're going to add the radical x plus 2 to both sides. Add it to both sides. So you have radical x plus 2 on the left. You have x on the right. Because we're adding it to both sides, it goes away over here. And now we have this. Now we isolated the radical expression. It's isolated. Let's go ahead and square both sides. Now we can square both sides. All right. Square the left side, radical goes away, x plus 2. Square the right side, x squared. All right. Square both sides. It's a quadratic. How do we solve a quadratic? Well, to solve a quadratic, you've got to get all the terms on one side. So we're going to move everything over. I'm going to subtract the x and subtract the 2, subtract the x and subtract the 2 from both sides, okay? So I'm going to put the 0 on this side, and I have x squared minus x minus 2. I have a quadratic now. Solve a quadratic, we can either factor or use the formula, and this quadratic is also factorable. So let's factor. All right, how do we factor this? X times x is x squared. We need a product of -2 and a sum of -1. So -2 and +1 will take care of that. All right, so then what would we have? Set this equal to 0. When is this quantity equal to 0? When x minus 2 is 0, when x plus 1 is 0. All right, so when we solve here, add 2 to both sides and take away 1 from both sides, and we're here. Okay, we're not done yet with the x-intercepts though, because we need to check these answers. We need to check these. We need to check these x values that we got. We have to see if they're going to actually work. We didn't have a problem with the first 2 examples because the domain of a parabola, the domain of a quadratic function is all real numbers. So no matter what you're going to get for x, it should work. The domain for your well, I mean, it wasn't a function, but the x's for your ellipse, those all worked as well. Those numbers worked for us. But with this one right here, it's a radical expression. You've got restrictions on your domains of radical expression. So we got to check these and make sure they work, okay? So we're going to come up over here, all right? And we're going to check our answers. We want to see if they work, all right? So we're going to check x equals 2. And we have to check x equals -1. We have to check these 2 answers and see if they work. How do we check our answers? We're going to plug them back into the original equation. Let's see if it's going to work in the original equation. Okay, and we want to see if it gives us, we want to see if it gives us a y-coordinate of 0. So 0 equals x minus radical x plus 2. So we're going to plug in 2 first. Okay, so 0 equals 2 minus radical 2 plus 2. So does 0 equal 2 minus radical 4? So 0 equals 2, square root of 4 is 2, so that works. Okay, yes, this works. Okay, so x equals 2 is a solution. This is one of our solutions and it works. Okay, what about x equals -1? Let's see, 0 equals x minus radical x plus 2. Plug in -1 for x. You have -1 minus radical -1 plus 2. So you have -1 minus -1 plus 2 is 1. So you have -1 minus 1, which is -2. And this is not a true statement. This is not true. So this is not one of your solutions. You have to throw this one out. The only x-intercept you have for this radical expression, the only x-intercept you have is the 2, okay? So 2 is the only x-intercept. All right, let's see what the y-intercept is. What about the y-intercept? To find the y-intercept, take the equation, set x equal to 0. So when you set x equal to 0, your y-intercept will be 0 minus radical 0 plus 2. When you simplify this, your y-intercept is going to be a negative radical 2. So there is your y-intercept, and that works out fine. Okay, so the y-intercept of these functions is usually a little bit easier to find. So what are the intercepts for this graph? Your x-intercept is 2, 0. That's your x-intercept. That's where it crosses the x-axis. That's how we write it. Your y-intercept, well, that's when x is 0, your y is a negative radical 2. Here, this would be the answer for this example. This graph right here crosses the x-axis at 2, 0, crosses the y-axis at 0, -2. All right. Hope this gives you a feel for how to find the x and y intercepts of a curve. Some curves are functions, some are not functions, but you can just use this method, okay, to find x and y intercepts of a curve. Thank you for tuning in, and bye-bye.